All right, boys and girls, we're going to look at dividing fractions, dividing unit fractions divided by a whole number, and dividing a whole number by a unit fraction with some models and different types of models. And so I'm going to go through this video with you, and I'm going to show you several different examples of something that you might see on your test and kind of how to break them down and how to analyze them. And so I'm going to start with number lines first. Number lines aren't too bad. I think probably you'll hear me say this a few times throughout this video. Anytime you see a model, there's a few things you need to keep in mind. But one, when you're breaking down a model or when you're analyzing a model, always think about, the first thing, especially on these problems, think about what you have. Think about what you're starting with. Think about what you're seeing. And so on this particular problem, I'm going to do some labeling as I talk. I'm seeing that there's a number line from 0 to 3. So I'm going to start by thinking, okay, they're starting me out with a whole number on this problem. So essentially, if you've watched some of my other videos, this is kind of a pizza problem because you're starting with a whole. And then what they've done is, and I'm going to do some underlining here, on every whole, they've basically cut it into 3, or they've cut it into thirds. So I see this problem developing here. I see that they're taking 3 wholes and then they're dividing it into thirds. And basically by doing that, if this is a pizza problem, I'm thinking, okay, well, if it's a pizza problem, I've got 3 pizzas and they've cut them into thirds. How many third slices do I have? And I can really just kind of go through and I can label here. If I kept counting them, I think I'm going to end up having 9, and sure enough, I do. And so on this particular problem, my algorithm would be 3 over 1 times, again, 3 over 1, and I would get 9 over 1, or 9, as my answer. And so really and truly, it's not too bad, but it's all about kind of going slow and really thinking about what do you start off with. Okay, this particular problem, it's kind of the same thing. I see a number line. I see 0 through 2. When, in thinking about it, when I see 0 through 2, my mind's already going, all right, they start me with 2. I'm starting with 2. All right, from here, I think they're breaking it up. Every time I'm seeing a whole, I see that they're breaking up into 4 pieces or 4 slices if it's a pizza problem. And so I'm thinking this one could be 2 divided by 1/4. And again, if I just go and I count how many fourths I see in that 2, then I think I'm going to read that there are 8, or my answer is just 8 pieces or 8 parts, or however you want to see it. So the algorithm would look like this: 2 over 1 times 4 over 1, get the answer of 8 over 1, or just 8 wholes. Okay, this particular picture is a little bit different. So really think about it. And this is kind of that part where, again, it's how you start it. It's what do you see at the beginning. All right, this time I don't see multiple holes. I see really just one hole. But I see that they've cut that into 6. So what catches my eye first on this one is when I'm breaking this down, I'm thinking more of maybe like that leftover problem, because now I'm not seeing just multiple. I'm not seeing like 2 holes or 3 holes or 8 holes or whatever it might be. I see that they took a hole and then they cut it up already into pieces, and they have that labeled, and they have it labeled as 6th. So I'm thinking, okay, well, maybe they took a 6th here and they divided that up into something. Well, if I start this out, I could start by saying 1/6. And if I just kind of focus in on this part right there, there's my 1/6. Well, they took the 1/6 and they cut it into halves, basically. Or they cut it into 2, or they divided it by 2. And so if I look at this problem, again, what I'm thinking about is I'm thinking about them taking a part, in this case just 1/6, and then they are splitting that up into 2. So if they do that, I've got to figure out what does this piece equal right there. Well, I could do that two different ways. I could use the picture or I could fall back on an algorithm. Well, if I fall back on an algorithm, that's going to be probably the easiest way if you understand the algorithm, but it's in the picture too. So let's do algorithm first. Let's think about what that would give us. That's going to be 1/6 times, remember the flip part is going to be thinking of this as 2 over 1 in the problem, in the original problem, but now I can take it and flip it and write it as 1 over 2 or 1/2. And I can multiply. 1 times 1 equals 1. 6 times 2 gives me 12. All right, I think if I took 1/6 and I cut it in half, that really gives me 12ths. And if I go up here and just think about now from the beginning, which it kind of got cut off, but that's a 0 there. But if I go from the left all the way to the right, I think if I count these, I would count 12. And so if I just kind of go all the way down and see how many there are here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that piece that I've got my arrow pointing to right there is really 1/12. All right, this next one, you could see some models that kind of resemble fraction strips. And that's, when you're looking at these problems, that's a pretty popular one. I've seen these on quite a few test questions. And so again, it's kind of thinking about what you have and what's taking place in that problem. Now, this particular one that I used, I had to use it off of an app that I have, and so I'm going to try to break it down. But as I'm talking, I might scratch some stuff out. So this one here that you see at the top, I'll put a check mark by it, is just showing that there's one hole there, and it's basically letting you see it like you would on a fraction strip. So if I really look at this, I see that there's 1/2 here in purple, and it looks like they took that half and basically split it up into 3 groups. So it's almost kind of like me saying, okay, well, hey, if I had a half to begin with, again, what do I start with? I'm starting with a half, and then they're going to take that and split it into 3 groups. And if I were to do that, if I were to take 1/2 and split it into 3 groups, then I should get the answer of just one of these pieces, which it's already labeled for you. It's going to equal a 1/6. And so again, with my algorithm, I could see that 1/2 times the flip, which would be 1 over 3, gives me 1/6, and that's what one of those pieces equals. So again, it's kind of, what are you starting with? What do you see? Also, I'll go back up to the beginning of this part here, or this picture. If you look at it, notice that there's not multiple holes. Okay, that's something to kind of keep in mind. There was just one. And so kind of keep that in mind when you're looking at these. All right, this one this was a little bit different, but it's kind of the same thing. I took the hole off of it, but I've seen a problem like this before where, they keep it pretty simple. I mean, it's what you have and what they're doing to it. So I'm going to look here at what I have. I'm starting with a 4th. But then they went and they took that 4th and then they basically cut it into 2 pieces. So here's one piece, here's another piece. Or they divided it by 2. You can think of it that way. And so now that I'm looking at this, if I go to algorithm, this would be set up as 1/4 times 1/2. I'd get 1/8. And again, if they cut it in half, one of those pieces would be worth 8ths. All right, this problem changes. It's still looking like fraction strips, but this problem changes a little bit because at the beginning, when I'm looking at it, now my eye catches something different. My eye is catching that there's multiple holes. There's actually 3. So right up here at the top, that's kind of where my eyes are going to go to first, and that is, well, now I'm looking at 3. That's what I'm starting with. So now they're taking 3 and they're dividing it into parts. Well, underneath, if I look and I just were to count here, I can count that on each hole they're cutting it into 6. So I think this problem is going to turn into 3 divided by 1/6. Now, Again, if I go back to what this is a pizza problem, or this is where you have multiple holes. So if there's three pizzas sitting there and they cut each one into 6 slices, you're thinking in your mind, how many slices do you have total? And I think by doing that, we could probably all agree that you would have 18. And so if I go and I just count and I really think about what's happening here on this picture, I think I would see that yes, there are truly 8 little pieces here. Or there's 18. There's 18 little pieces, or there's 18, 1/6 pieces on this model. I could prove it by doing the algorithm. 3 times, and then the reciprocal, or the flip, would be 6 over 1, which is going to give me 18 over 1, which then gives me the 18. All right, this one here, kind of the same thought process. I'm starting again with 3, but then on this one, I'm dividing it, and I'm dividing it into halves. I'm taking those 3 and I'm dividing it into halves. And when I do that, again, what's going through my mind is, okay, if I've got 3 pizzas, I cut them in half. How many halves do I have? And simply, you could think of that as, in your mind, what would that look like? Whether it be 6 of them, 1, 2, 3, 4, 5, 6. And so again, showing the algorithm just for proof would look something like this. You get 6 over 1. 6 divided by 1 gives you 6. And so there you're looking at a pretty easy problem. But again, it's just, how are they going to show it to you? Most of the time on these, when I'm thinking of STAR tests, they like models. They really do. And so models are very popular. So it's very important that you practice these. Okay, the last type that you could see is maybe just kind of a basic model with pictures. We're just kind of thinking about a hole and or multiple holes. In this case, that's what you see on this one. So they're just using, it kind of looks like fraction strips, but they're basically just using a rectangle to represent a hole. And so on this particular one, again, it's all about what do you have. And so on this, I see that there are 6 right off the bat. If I were to count them, there's 1, 2, 3, 4, 5, 6. So I would start with the 6. And then I would think about, well, what are they doing with that hole? Well, they're taking that hole and then they're cutting them into fourths. If I just take this bottom right one here, I could think, okay, well, that's a fourth, that's a fourth, that's a fourth, and then that's a fourth. So they're really taking 6 and dividing them into fourths. So again, I keep going back to this, but think about something that makes sense to you. If you are looking at, these are rectangles, so that doesn't really remind me of a pizza, but I could think of it like that. I could think, okay, well, if there's 6 pizzas and they cut them into 4 slices, how many slices would you have? You'd have 24 slices. And I can just go through and I could count every piece here, and I could get my answer that way. Or I could simply switch it over and think algorithm. I could think 6 times the flip, which would be 4 over 1. 6 times 4 is going to be 24. 24 over 1 gives you the answer of 24 again. Okay, this last picture changes a little bit. This one, and I had to label it just to kind of make it, maybe make a little bit more sense to you. But basically they're using what kind of looks like a fraction strip, but what they're doing is they're taking a whole, and I put the half there, they're basically showing you a half. But within that half, they're splitting it up into 3 pieces. So in your mind, you're thinking, okay, if I have this bar right here, and I'll draw an arrow to it, if that's my half, well, really I'm taking a half and I'm splitting it into 3, which means I should have smaller pieces as my answer. And if I go back up, I could see it in the picture. If I really wanted to, I could just label this and label what is actually happening here. You've got basically 6 happening. Because if I look at it as a whole, the whole thing would be 6, 6. Half of it would be 3, 6, and 3, 6 equals a half. But you just care about that shaded part. When they shade that, that's really them saying, okay, well, that's what I want for my answer. So I'm going to write it down here so we can see it a little bit better. But again, this is me taking a half and dividing it by 3 and going, okay, well, if I show my work here, 1/2 times the reciprocal or the flip would look like 1/3, and I'd get an answer of 1/6. So really and truly, I know I do this in my class. A lot of times what we do is we just put up a picture on the board and we just talk our way through it, because that's really what you have to be good at doing. When you see these pictures, you've got to be able to analyze them. You've got to be able to think. And I think on these, and again, I'm going to go back, I'll say it one more time. It's about what do you have to begin with. If they're giving you a unit fraction to begin with, then your answer is going to be a unit fraction. If they give you multiple wholes, then your answer is going to be a whole. I mean, it's really simple. Think about the picture that they're giving you before you start even trying to break it down to get an answer.